The world is changing, and we need to act now if we want to preserve our planet. Reducing the ecological footprint of our economic activities has become the #1 priority in all technical innovations. New techniques are finding their way into the industry to achieve the net zero targets. In addition, older and proven concepts like hot charging have resurfaced. Hello, my name is Jurgen Roeland, and next to me is my colleague Pieter Knoop.
We are PSI Metals solution consultants, and together we represent over 50 years of experience in detailed line scheduling techniques on the hot end of steel production. Today we will be talking about hot charging and how applying efficient production techniques in planning and scheduling can lead to a lower impact of decarbonizing coil production. It is a process that happens between the cutting of a slab at the caster and rolling the slab in the hot strip mill. During hot charging, we recycle the remaining temperature of a slab after the cutting process to reduce the required reheating time in the furnaces at the hot strip mill. This will speed up the transit time through the furnaces and increase productivity in the mill. The benefits of charging hot slabs are that they can move faster through the furnace and they need less reheating time. Hot charge programming also leads to fewer slab movements and a better organization of the pre-furnace area in the slab yard, and will eventually reduce slab yard size and minimize crane operations.
Well, this sounds like a magical formula. You might wonder, why doesn't every steel plant run their slabs in hot charging mode?
Well, unfortunately, things are not as simple as that.
Why not?
Slabs are rolled into coils in cylinder campaigns, also called hot strip mill program sequences. Hundreds of scheduling constraints impose how slabs should be rolled in sequence. Next to physical and line-based restrictions, there are also logistic decisions and planning considerations that affect customer delivery dates. In order to have an impact on productivity, every single slab in the furnace should be charged hot. The furnace can only move as fast as the coldest slab in the reheating zones of each furnace. A single hot charge program may have a small efficiency improvement. The real benefit will only come when multiple hot charge programs are produced in sequence and spread over the active furnaces. There are many conflicting interests between both installations when it comes to hot charge optimization. Hot charging is a compromise in balancing productivity of both lines in order to improve energy consumption, reduce CO2 emissions, and increase hot strip mill throughput. The consequence is a minor decrease in productivity at the casters and a smaller grade mix at the hot strip mill. Hot charging can be done in two different ways, called the opportunistic and planned hot charging. At PSI, we prefer the planned hot charging approach. With PSI scheduling solutions, we support the schedulers and solve the hot charging problem by using the caster scheduler and the line scheduler tools for the scheduling. Caster scheduler is a dedicated scheduling solution for continuous caster programming, and line scheduler is a scheduling solution for hot strip mill scheduling. By collaborating, we achieve an exchange of supply and demand of hot slabs using a pull-push mechanism which is able to combine multiple hot strip mill programs into a single caster sequence by using the best scheduling algorithms available to both environments. Once the caster schedule is available, there will be deviations from the original order request because of caster optimizations. But it remains a planned approach where deviations are re-optimized during the push phase.
The pull run begins at the line scheduler with virtual slabs. These slabs are created based on the remaining open order balance of production orders according to the slab dimensions received by order dressing. The balance is at that point already adjusted by previous pull demands, which makes the generation of the new pull demand an incremental process. The aim is to provide an exact order mix to the caster, which ensures that ideal hot strip mill programs can be produced in the most optimal way. The scheduler can decide to build one or multiple hot charge programs at the same time. The pull run already takes into account high-level caster wishes, such as limiting the amount of steel grades and favoring big width blocks in the same program in order to avoid passing an infeasible mix to the caster.
As caster production is not always completely reliable and a certain percentage of dropout may be expected, a pull program will typically overschedule the length of the template by 5 to 10%. The demand sent to the caster scheduler is a request for a fractional volume of each individually planned production order, accompanied by the hot charge program identifier. After this stage, we have the caster scheduler run. The goal of this run is to schedule the slabs programmed in the pull run on the different casters. Timing is crucial in this process. Every slab programmed on the hot strip mill must be scheduled on the caster within a well-defined time window. If it is scheduled too early, it may have cooled down before it is expected in the reheating furnace. If it's scheduled too late, it will not be in time for the hot rolling program. Caster scheduler will receive the pulled slabs as order splits together with the allowed time range. The remaining orders, not eligible for hot charging, will also be part of the input. The scheduler now has the task to create a schedule for the next few days where the hot charge orders are integrated with the other cold charge schedules. Maximization of the amount of hot charge material scheduled within their time period is key here. The main complexity comes from the often conflicting scheduling rules that apply on the casters. First of all, the scheduling unit is not a slab, it is a heat. This means that roughly 200 to 300 tons of the same quality must be combined in a single consecutive batch. Furthermore, and contrarily to the mill, wet changes should be avoided as much as possible. They decrease the productivity and can cause the introduction of unapplied material or even breakouts. The same applies to the grade changes. They cause the introduction of transition slabs, which may introduce more unapplied material or even scrap, while the scheduler should maximize the productivity of the casters. Utilization of the tundish must be maximized. This can only be achieved by combining the hot charge orders with the rest of the order book. Every slab in the schedule will have an estimated cutting time at the caster. This information will be used by line scheduler in the push run to predict when the slab will be available for charging to the furnaces.
The final stage is the push run, which is the final creation of the hot strip mill hot charge programs. We use the forecast slabs received from all the casters and are still able to identify what slabs were produced against which original hot strip mill pull program. As with all things in life, we never really know if we will receive what we originally asked for until we see it appearing in our inventory. In scheduling with complex casting rules, we can have the same expectation. Caster scheduler will have added more slabs to complete a heat or a tundish, giving us more than we originally asked for. Sometimes we get the full demand, but we could also get less slabs for slabs that did not make it to the caster schedule because they are simply too constraining and therefore left out. In this case, we may be left with new hot strip mill scheduling challenges and rule violations. By entering the original pull number, the system will favor the original demand, but we'll also try to add the new ones and potentially use single slabs from other hot charge demand in order to overcome difficult scheduling transitions.
In a final step, a furnace optimization algorithm will assign each slab to its ideal furnace, taking into account slab furnace restrictions, optimizing furnace temperatures and throughput. The result is a final hot charge mill program based on actual caster supply.
Imagine you have a solution that not only supports you with your metals production challenges, but at the same time decarbonizes the industry. PSI Metals can support and provide solutions that will increase your hot charge rates, balance the productivity of the continuous casters and the hot strip mill, optimize the use of the reheating furnaces, and improve longer horizon visibility on the planning and scheduling horizon. We are your partner in developing long-term, sustainable and ecological solutions for the challenges we have ahead of us. Thank you for watching. Feel free to reach out to me and my colleague for additional information. We hope to see you soon in one of our PSI Metals locations.